All right, so today what we're going to do is we're going to talk about finding and when we need to find common denominators. And we're also going to talk about adding and subtracting fractions. Okay? And those two things go together, right? Now, did we have to have did we talk about common denominators before? No. And what two operations did we use before?
Multiplication and division.
Multiply and divide. So therefore, do you always, for every mathematical operation, need a common denominator? No. Not for multiplication and division, but it is absolutely critical. You cannot add or subtract without a common denominator, right? So make sure that you're keeping those when you need to have that piece of information separate. Okay, so the first thing we want to do is talk about common denominators. Okay? In order to add or subtract fractions, you must have a common denominator. And I've already written common denominator, so now I'm just going to abbreviate it, CD. Okay? Remember, capital D always means denominator. And capital C will always mean common, by the way, too. Okay? Now, you have probably, well, I know you have. If you've added or subtracted fractions, you've learned some method for finding a common denominator, either using factor trees or just guessing or whatever, right? The most common way in junior school is just they tell you to multiply the two denominators together and use that big number. No like it, okay? And also let me tell you that if you try that in algebra, you're going to dig yourself a hole that you'll never get out of. Because in algebra, the denominators of fractions, and you do not have to write this down, are going to look like this. If that's the first denominator, and this is the second denominator, do you really want to multiply those two things together and use that as your LCD? No. Okay? So again, that trick works. And if you get in a bind and you're working with just arithmetic, meaning just numbers, no algebra, go for it, right? Better to get an answer and then have to simplify the heck out of it at the end than not be able to get an answer at all, right? But I'm going to show you a technique that works no matter what, even if the denominators look like that. Okay? And so, again, you're not going to have to worry this technique is going to look like way overkill right now, but you can expand on it and use it for bigger things, right? So, the first case is if you have a common denominator, if the denominators are the same, then you just use the denominator you have, right? So if your denominators are both 5, then who cares? We'll keep it, right? But if you don't have a common denominator, if the denominators are different, I'm going to show you a method called upside down division. Now again, it's going to look kind of convoluted to use to you in the beginning, especially if the numbers are small. But when the numbers get bigger, then you'll thank me. Trust me. All right, so we're going to get an example going on because this was one of those things where because just saying upside down division already freaks a lot of you out, right? Doesn't mean we're going to stand upside down and divide. That means we're just going to use the division symbol upside down. The regular division symbol looks like this, right? Well, we're going to use it like this, which is the way most of the world uses it, by the way. All right, other than the English-speaking people. So here we go. So we have our division symbol, right? And here's what we're going to do. First, put the denominators in an upside-down division symbol. This takes a lot more writing than it does doing. Okay? So let's say we have the fractions, I don't know, 3 over 15. No, that will reduce. We don't want that. 4 over 15 plus 7 over 24. Who cares? Right? Now, I picked numbers purposely where that multiply the two denominators together would be a nightmare, because if you did that, you'd have to take 15 times 24. You're going to get a huge number. And what happens when you're working with really big numbers? Yeah, we don't like that. We don't like to do it, and we're a lot more prone to make mistakes. Now, you're going to have calculators, so you're not going to be that nervous about it. But if those were algebraic, you can't do them with a calculator. Okay, so this is what I mean. We're going to take our first denominator, which is 15, and our second denominator, which is 24. Make sure you leave a little space between them so that you don't get them too packed up, right? Now, well, it's still a division symbol, even if it's upside down. So what do you think the next step would be? Divide, maybe, all right? Okay, answered my own question too quickly. I should let you do it. All right, then what you're going to do is simply divide out common factors. Same idea that we use for simplifying, except this time we're not just going to eliminate those common factors. We're going to use them to find the LCD. So looking at 15 and 24, is there anything that will divide evenly into both 15 and 24? 3. They'll both divide by 3, won't they? Okay. So let's divide. What's 15 divided by 3 going to leave? 5. Whoops, sorry. 5. So you just write it underneath the number you're dividing by. Write that quotient down there. 24 divided by 3 is 8. Then you need to look at it again and see if there's any more common factors. Is there anything common to 5 and 8? No. So as long as there's nothing common to them, then you know you're done doing the division part. Now what if there was something common to them? I'd need to continue as long as there were any common factors. And sometimes you'll divide 2 times, 3 times, depending on how many fractions you have. If you have the more fractions you have, the more factors you're going to find. Then simply take the LCD, which is least common denominator, is the product. What do I mean by product? What operation is a product? Oh, be careful. Yeah, there you go. Multiplication. Yeah, it's all right. Repeated addition. Multiplication. The product of every factor on the outside. Now, I didn't write the product of the factors on the bottom, did I? I wrote the product of every factor that is where? On the outside of the division symbol. So that means the 3 and the 5 and the 8. And remember, I use the dot. You can use an X if you want to use for multiplication. Get used to me using the dot, but because I can't help it. I'm old. Y'all are more flexible than I am. Okay, so now let's just multiply. So what's 3 times 5? 15. And 15 times 8? All right. Yeah, or you could take it a different way. 5 times 8 is 40 times 3 is 120. Remember, you can multiply in any order, so if you see some that make your life a little easier. So our LCD is 120. Now, 120 is still a big number, isn't it? But it's not as big as 15 times 24. Did somebody want to multiply 15 times 24 and tell me what that would be? Somebody have a calculator, sir. 360. Now, 120 is still big. Okay, I wish I could do that. All right. 120 is still a big number, but it's not as big as 360. Oh, but that makes perfect sense because it's just got a factor of 3 removed. Genius. Okay. Teaching math for 25 years, and I'm still surprised some days. Oh, well. Okay. Yes?
In that case, could you just do 15 times 24 and then divide it all by 3?
Well,
That'd be faster.
you could, but you'd have to know that 3 is what you're dividing by. How did you decide to divide by 3?
But then in that one, the one we did first, we just looked at 15 and 24 and found that 3 is the...
Right. So you would have found the common factor first and then multiply the big numbers. Well, multiplying 3 times 5 times 8 is probably easier.
Yeah, so.
Yeah. So I'd work with the smaller numbers. Your logic is spot on. I absolutely agree that, yes, you could do it that way. I don't like to do it that way because I like to work with smaller numbers, but it doesn't matter. Okay? And most people are more comfortable, there you are, multiplying than dividing. Okay? But yeah, you bet you can. Now, so there's how you get your LCD. Okay? Now, it works with any numbers. It works with more than one number. So say you have 4, 12, and 15. Because there will be times when you have to add or subtract more than one fraction, right? And you have to have an LCD for 3 fractions. Looking at this, we put them in our upside-down division symbol. Not even worried about the fact that I'm not going to write fractions. I'm not worried about that part yet. Just worried about the LCD. Is there anything that would divide evenly into 4, 12, and 15 all at the same time? No. But is there anything that will divide into at least 2 of them at the same time? Yes. So if there is a common factor anywhere, it has to come out. Right? It doesn't have to divide evenly into all of them. So what do you see? 4 and 12 will both divide by 4, or 12 and 15 will divide by 3. Does it matter, do you think? Nope. So let's divide out the 4. 4 divided by 4 leaves you a what? 12 divided by 4 is? Will 15 divide evenly by 4? Nope. So it's not going to change. We're just going to bring it down. It still exists. Okay? Now, do we still have a common factor down there? Yep, 3 and 15, which means I need another symbol. Because I always have to keep those things I'm working with separated from the answers. What's common to 3 and 15? 3. 1 won't divide by 3, so you just bring down the 1. 3 divided by 3 is 1. 15 divided by 3 is 5. Is there anything common to 1, 1, and 5 other than 1, which doesn't do you any good? Because if you divide by 1, you get right back to where you started. Nope. So these are the factors of my LCD. And since some of them are 1s, who cares? Because we don't multiply by 1 either, right? So it's just 4 times 3, which is 4 times 3, which is 12, times 5 is 60. Okay? So your LCD is 60. Now someone want to do this multiplication for me? 4 times 12 times 15? Anyone? Come on, you got your calculators. Use them. What now? 720. Would you rather use 60 or 720? All right? So, and again, the only reason I'm doing that, showing you that, and talking about it that way is that I'm going to tell you that those junior school tricks work, but in junior school, you were using 2s and 4s, right? And in high school, you're going to be using much bigger numbers. You don't want to work with 720 or whatever it was when you could use 60, right? So, now, this is a process. Is it the be-all, end-all process of all time and the perfect process you must use for the rest of your life? No, I don't care if you use it or not. I'm just offering you an alternative that always works. And that's what we like. Patterns that always work. Not patterns that work for this one, then we have to learn a new pattern for that one and a new pattern for that one, right? Okay? And that's what I'm always going to show you is I'm never going to show you shortcuts or special cases unless there are very few times. Sometimes there are a few shortcuts that happen so often that you should just keep them as tools. Okay? All right. Now again, you do it the way you want to do it, but that is one way. Second thing we need to know, if you change the denominator, you must also change the numerator. Because 1 piece out of 5 equal pieces is not the same as 1 piece out of 60 equal pieces, right? So if you change the denominator, you're also going to have to change the numerator to match it. Okay? And you're going to be multiplying by a factor. I'm not sure how you were taught this before. Don't care. But I'm going to show you another method. And now, and this one most of you probably will not have seen, but I love it. And the reason I love it is because it translates to so many things. When you're eliminating fractions from an equation, you can do this. When you're combining fractions, adding or subtracting fractions, you can do this. If they're algebraic or just plain arithmetic, you can do this. It always works. Now, it is probably going to be new to most of you. I've never met a student in New Zealand who's seen it before. So if it's new, then sometimes it's uncomfortable, and so you don't want to change. So if you have a method that already works, don't change. But if you have a method that works sometimes, change. Right? Go to one that works always. Here's what we're going to do. Okay? First, you're going to rewrite the problem as one fraction using the LCD, the common denominator you just got. Okay? All right. Let's mess with an example. Let's say, what do we use? I just used 4, 12, and 15. Let's just get some numbers working here. Say it's 3/4 plus, 5/12 plus, that will be easy, and just do that as a 1. Okay? Now, we just found the LCD for those denominators, didn't we? What did we decide it was? 60. Now, when we're working, here's another thing. I want you to change one thing. Change that last plus. Ooh, darn it. Change this last plus to a minus, just so that you can see it. It makes no difference. All right. Our whole goal is to put these three fractions together as one fraction. Isn't that what you do when you add and subtract? Take a bunch of pieces and put them together and make one? So let's write it as 1 in the first place. So what I'm going to do is just make a big fraction bar and put my common denominator in the bottom. There's no reason to rewrite it as 3 different fractions when our whole goal is to make it 1 in the end anyway, right? Now, second thing. Divide your original denominator by the LCD. Now you're going to repeat this for each fraction because you have 3 original denominators, right? So each one of them is going to have to be handled independently. Does that make sense? So let's do the first one. What is my LCD? 60. What is my first denominator? 4. And what is 60 divided by 4? 15. Do we all agree on that? So all I did was take this number divided by that number. So 60 divided by 4 gives me 15. Okay? I don't like it. I wrote it there, but that's okay. Third, multiply that quotient, and yes, I'm using that math word on purpose. Quotient is the answer you get when you divide, right? So that 15 is the quotient. That quotient times the original numerator. Okay, that says original. It doesn't look like it, does it? The original numerator. Okay. So my quotient was 15, so I'm going to take 15 times 3, and what does that give me? 45. Yeah. And that goes down here. That's your new numerator. This product, again, I'm using math words. Product means multiplication. This product gives the new numerator. Again, it takes a lot longer to write out than it does to do. Doing it's fast. Okay. So, divide the LCD by the original denominator, multiply what's left times the numerator. Okay? All right. Let's look at the second one. So again, our LCD is what? 60. What's our next denominator? 12. What's 60 divided by 12 make? 5. And we take that 5 times our original denominator of 5, numerator of 5, which 5 times 5 is 25. Now, don't forget, we're adding and subtracting, so don't forget the pluses and minuses come down between them. You should have brought the plus down first, okay? All right? So let's bring down that minus, and let's do the last one. 60 divided by what? Well, just 15, right? Because we brought the negative down already, the minus down. 60 divided by 15 is 4, and 4 times 1 is 4. Now it should be painfully obvious what to do next. What? 45 plus 25. Yeah, you just add and subtract, right? It's all one fraction with a bunch of addition and subtraction in the top, right? So do it. 45 plus 25 is 70 minus 4 is over. And now, with multiplication, we've simplified first. With addition or subtraction, you still have to simplify at the end. So what's common to 66 and 60? There's something obvious. 6, which gives you 11 over 10. And that's an improper fraction, which is perfectly fine. Don't change them to mixed numerals unless you're asked to change them to mixed numerals. So if the top number is bigger than the bottom number, who cares, right? Now, if you're answering an application problem, then you might want to change it. But in algebra, this is the way you write your answer. So I'm fine with you leaving it like that, right? Now, you can convert them, and we will convert them for some of the applications, right? What would that be? 10 goes into 11, what? 1 time with 1 left over, so it'd be 1 and 1/10, right? Now, this is the format where I would prefer you leave it. But this is the format if you were answering a question. Because let's say we were talking about our answer in time. Again, the only time you would do this second format is if you were answering an applied question. For example, you wouldn't say, how long did you sleep last night? Oh, 15 over 4 hours, right? That doesn't make any sense. But if it was like 7 1/4 hours or something, do you see the difference? But mathematically, you cannot use this one to multiply or divide. But you can use this one all day long, right? So mathematically, if you want to have a number that you want to use, this is the one, right? So don't go back to junior school on me here and change everything to this. Keep them as improper fractions, because those you can multiply and divide with. If you change to 1 and 1/10, and then we're asked to do any math with that number, you'd have to change it back, which is ridiculous, right? Okay? Now, again, be careful. The directions may say convert to a mixed number or mixed numeral. Then you have to do it, right? But if it doesn't specifically say it, and it's not a word problem where it makes more sense to use it, don't. Why make more work for yourself? Okay? And in algebra, this is what we always want, unless you're talking about time or some kind of units that just don't work with improper fractions. Okay? All right. We'll stop there. Just